Hello, everyone. Welcome to my presentation. My name is Kwame Ampon. I am a graduate student at the University of Alberta, and I am studying plant science. Today, I'm going to present on the topic applying humalite for enhancing wheat production and soil health. Increase in food production has resulted in increase in nitrogen fertilizer use, and this increases the cost of the farmers. As we can see here in the graph, increase in urea prices have been observed for the past year, and even for the last couple of months, they are seeing an astronomical increase. And so therefore, conscious effort must be made to reduce the amount of nitrogen fertilizers that we apply on our field. Surprisingly, more than half of the nitrogen fertilizer that we apply end up being lost through soil erosion, ammonia volatilization, nitrification of ammonium, and also denitrification of nitrate. So the nitrate leach into our water bodies to cause eutrophication and also other environmental pollution. So this decreases the amount of nitrogen, or this decreases nitrogen use efficiency, and various mechanisms have been used to improve the situation. These include agronomic strategies such as cropping systems and also mode of fertilizer application. You also have biological and synthetic nitrification inhibitors that slow down the rate of conversion of ammonium to nitrate. You also have molecular techniques such as breeding for high nitrate transporters that can take up nitrate. And also you have the use of humic acid, which is really found in organic amendment. And we also have example is humalite, which is which contains a lot of humic acid and which is of really critical importance to this research. And so, like I said, the humalite is a naturally occurring organic amendment which is found in high deposit in Alberta, and it contains more than 70% humic acid, and also it contains high soluble carbon. And here on the right, you can see the picture of humalite is really black. And some of the functions include improving soil biological activities such as microbial growth or microbial biomass in the soil, which is good for soil health, and also the chemical properties of the soil, such as improving the cation exchange capacity, and also physical activities of the soil, such as improving soil structure and soil texture. So all these culminate in binding nutrients in the soil, which helps the plant to take up nutrients in a more efficient way. So the overall objective of this project was to evaluate the application of humalite and urea fertilizer on wheat agronomic parameters and soil health. The experiment was carried out in a typical crop rotation program in Alberta. So this year, wheat was grown, and next year we are going to plant canola. So the experiment was carried out in May 2021 at Gate Research Organization, which is at the north of Edmonton. So I'll mention as GROW in my subsequent delivery. We also have the Battle River Research Group, and I'll mention it as BRG in my subsequent delivery. And it is found at the northeastern part of Edmonton. So the experiment was carried out in a split pot design, so where the urea was the main pot, and we have 3 levels of urea, which is no urea, half recommended, and also full recommended urea based on soil test. And also the humalite was on the subplot. We have 5 levels up to 800 pounds per hectare. The seeding was done at the end of May 2021 and harvesting was done in early September 2021. These are the results at the growth site on height, yield, and protein content. And as you can see, there were significant differences in the treatment in height, yield, and protein. So the higher height was found in the treatment of half urea and 100 pounds per hectare humalite, and also the lowest found in the no urea and 0 and 100 pounds per hectare humalite. But as we can see, even though the highest was found in treatment and humalite, we didn't see much clear difference between the treatment, as most of the figures have the same letters. With respect to the yield, full urea and high weight of humalite significantly increased yield as compared to all the treatment. With respect to the protein concentration or the protein content, the highest protein content was found in the treatment of full urea and 100 pounds per hectare humalite. But as you can see, even the 0 humalite application also had significant results, and so therefore no clear difference or no clear effect of a humalite can be made. Also, the interaction effect of urea and humalite at a BRG site on height, yield, and protein content. We can see that there were significant differences between the treatment. For example, the height, the lowest height was found in no urea and 0 humalite treatment, while the highest was found in no urea and 200 and 400 pounds per hectare humalite application. But as we can see, even with no urea and half urea and full, sorry, with no humalite and half urea and full urea, we found out that it wasn't significantly different from the humalite treatment. And so therefore, we didn't have clear difference of humalite treatment. With respect to yield, we saw that half urea and 200 humalite treatment had significant effect on their yield. With respect to the protein content, the highest protein was found in full urea and 0 urea treatment, and so therefore they didn't have any effect of humalite on the protein content of wheat. This interaction effect of urea and humalite on soil pH at both sides, and so therefore the red bar is the baseline soil pH, and as we can see, we witness a decline of soil pH across both sides. And so therefore, even surprisingly, the control, that is the no humalite and no urea, also had a drop in the pH. So in effect, we didn't have, we had a significant drop in the pH in all the treatment, but we didn't have any differences between the treatment. The interaction effect of urea and humalite on soil active carbon at both sites showed that both sides had an increase in soil active carbon in the treatment. As you can see, the baseline active carbon is really lower than that of the treatment, but we found significant differences in the treatment at a GRO site. And as you can see, the highest active carbon was found in no urea and the highest amount of humalite. And so even with that, we can see that the no humalite application had almost similar results with the humalite treatment. And so therefore, we didn't see any much significant effect of humalite on soil active carbon. With respect to BRG site, we didn't see any significant difference between the treatment. The interaction effect of urea and humalite on soil ammonium, as we can see at both sites, we had an increase in ammonium concentration in the soils. And we also have significant differences between the treatment. And as we can see, highest amount of ammonia concentration was found in no urea, and also highest amount of humalite that was applied. And so therefore we can see that in most cases, the humalite had effect on the ammonium concentration. And as you can see at the BRG site, we saw that full urea and 300 pounds per hectare humalite had significant effect on the ammonium concentration in the soil, but they were not significant from that of the full urea and no urea, and also 100 pounds per hectare humalite. And as you can see, at the no humalite treatment, we had similar results with some of the treatment with humalite. And so therefore we can see that we didn't have a clear effect of the humalite on soil ammonium concentration. Then the interaction of urea and humalite on soil nitrate, as you can see, again, we had an increase in nitrate concentration in the soil at both sites when we compare it with the soil baseline nitrate. But as you can see, we had the highest increase in ammonium concentration was similar in most of the treatment. For example, under no humalite treatment, the result was similar to the humalite treatment, and so therefore we didn't see clear difference between the humalite treatment and non-humalite treatment. The same happens to the nitrogen concentration in a BRG site. As you can see, zero humalite treatment with full urea increase the nitrate concentration in BRG site, and so therefore we can see that the urea application had effect on the nitrate concentration in the soil. When we compare both sites, we saw that BRG had higher yield as compared to GRO, and when when we have higher yield, definitely it will correspond with lower protein concentration as it was observed. So with respect to protein content, BRG had lower protein concentration or content as compared to the GRO. With respect to ammonium and nitrate, at both sites, we saw that GRO had higher or could retain more ammonium as compared to the BRG site. So therefore, it is very good at the GRO site since we had more ammonium in the soil. These are my conclusions. Full recommended urea and high humalite rate application significantly increased wheat yield at GRO site as we saw it, and also half recommended urea and 200 pounds per hectare humalite significantly increased wheat yield at BRG site as we saw it. Also, application of humalite did not have much or clear effect on soil pH, active carbon, ammonium, nitrate concentration in the soil. So we recently saw that site had effect on yield, protein content, and also soil, ammonium, and nitrate concentration in the soil. And I want to acknowledge our sponsors, that's the Radar, Grow, BLG, and also BGRF. These are my references. Thank you for your time.